Welcome. This is the 5th video about numerical summaries, and our goal for this video is to discuss the 5-number summary, because in the next video we want to describe another measure of spread called the interquartile range. So the 5-number summary attempts to summarize a list of data, a distribution, into just 5 numbers. So instead of looking at a whole list of numbers, we were summarizing things into an average or a standard deviation or a median. This is giving us a little bit more options than that, or a little bit more to look at than that, and that we'll get 5 numbers. And you've already met 3 out of the 5, so the minimum value is one of the numbers in the 5-number summary. Sometimes it's given this label Q0, and that 0, or sometimes called Q0, and that 0 is a little bit below kind of the writing line. So it's a subscript. And all the numbers in the 5-number summary will have a label like that. So the Q0 is just the minimum value. Q1 is maybe the new one, and it is a number in the distribution where a quarter, or 25% of all the values in the distribution, are less than Q1. And that implies that 3/4 are larger. Then we get to the median, the number in the distribution, where 50% are larger, 50% of the data is larger, and 50% of the data is smaller. Q3 will be matched up with Q1 in that it's the value where 25% of the data in the distribution is larger, so 75% is smaller. And then the maximum value, sometimes Q4, is the value where every other data point is smaller. So it's like if you have an ordered list of data, the minimum Q1, median Q3, and Q4 divide up the data set into chunks so that you have 25% within each chunk. So if you had a number line, and then all these dots were going to represent data on the number line, starting to stack up in places. Then what you're trying to do with the minimum, Q1, Q2, or the median, Q3, and maximum, so Q0, Q1, median, Q3, and Q4 maximum, is that each little area contains 25%. And you might have like this little piece right here is still 25% of the data, even though it's a smaller bin. So you're kind of putting checkpoints along the way. And then to make this accurate, it looks like we might need one more dot there. So let's do an example where we actually have numbers. So let's determine the 5-number summary for the distribution of areas of counties in Oregon. So each one of these numbers represents the area of some county in Oregon. So it's nice to organize the 5 numbers into a table. So you have Q0, Q1, Q2, Q3, and Q4. And remember, the odd numbered one, that's not true. The even numbered ones have special names: median, maximum. And the way that we think about calculating these numbers, like the median, would be to find the number that's in the halfway point. And so this data set is already ordered, so that's going to make it easy. So that's what I mean by calculating the median. We think about calculating it as the halfway point once we have an ordered list. So it's very convenient that this list is already in order, because we can piece out that with 4 rows, each row is already worth 25% of the data. So notice, take note of that. This is 25% of data in each row. So that's going to help us figure out Q1, Q2, and Q3, because those numbers were all about parsing the data into at 25% increments. So let's write the minimum is easy to spot, is 435. It's the smallest number in the list. And the maximum is also easy to spot, 10,135. The median we can piece out by getting a number that's between the halfway point. So we did this in a previous video, but we need a number that's between 1781 and 1868. And the way that we've done that before is actually somewhere previously in this list. There we are. 1781 and 1868 added together are 3,649. If we take the average of those two numbers, we need to divide by 2. And we have 1824.5. 1824.5. And again, think about what that number does. Half the numbers are less and half the numbers are more. To get Q3, we're wanting, or Q1, we're wanting to further divide the list. So let's do Q1 first. So we want a number where 25% of these numbers are below and 75% are above. So we want a number that's larger than 827 but less than 980. And the way we're going to get that is again through an average. 1807 divided by 2 is 903.5. And similarly, we want a number that's smaller than everything in that highlighted list there on the bottom, but larger than all the numbers above it. Larger than all of these numbers in blue. Because that'll represent 75% being smaller and 25% being larger. So we want to average 3,068 and 3,145. So we first add those numbers together and then divide by 2 to get an average. So this is 3,106.5. So you have these 5 numbers, and these are kind of like the boundaries or extremes. This is somehow measuring the center, even though it's not halfway between the two boundaries. It's halfway in the sense that half the numbers in the data set are below and half the numbers in the data set are above. And then these Q1 and Q3, you can almost think of them as center of lower half and center of upper half. They're medians in their own right. Center of upper half. Alright, so that's the 5-number summary. In the next video, we will use the 5-number summary to calculate a measure of spread, the interquartile range.